Lesson 2.1.2, How High Will It Bounce? In this lesson, students will investigate the relationship between the height from which you drop a ball and the height to which it rebounds. After introducing the lesson and teams have read the beginning problem, give them about 5 minutes to discuss and determine the measure of a ball's bounciness.
Can't we work out a ratio for the rebound height as compared to the starting height of the ball?
Yeah.
Yeah. So we could do that to figure out which ball is bounciest in the balls that they gave us. I think that the basketball is the bounciest because if you do the ratio 53.5 inches over 72 inches, you'd get a rebound ratio of 0.743. Is that what you guys got?
Yeah.
Okay.
Following the calculation, move teams on to 221, where they devise an experiment for determining the bounciness of their own ball.
Guys, I have an idea. We should drop the ball from 200 centimeters and Will, you could drop it since you're the tallest.
Oh.
And I could record how high it bounces.
That would work.
Yeah, why 200 centimeters?
Because that's what mostly these ones in problem 220 were using.
Okay. Are we going to measure it with tape measures?
Yeah.
Okay. I think that would work well.
I do too.
And then we can just use the ratio of the bounce height over the drop height, right?
Yeah.
Should we let her know?
But wouldn't you need more than one height for a ratio?
For the ratio you wouldn't.
Oh.
Maybe for the graph though, because for 222 we have to graph it.
Oh, okay.
So we should have.
Yeah, because we need different points.
Yeah. What heights should we use though?
I think
150.
175, 125.
Okay. Alright, let's let her know.
Once teams have developed a method, send them over to take their measurements.
Okay, you guys have a plan?
Yeah.
What's the plan, Danny?
We're gonna drop the ball from various heights to see how so we can get the ratio of how high it bounces.
Okay, do you have your reporter?
Yeah, that's me.
Okay. What about spotters?
Beacon spot.
Who's your dropper then?
Will's the tallest.
Okay. Different heights. How are you changing the increment?
25.
Okay. Other question that I might have is what part of the ball are you going to measure? The top of the ball, dead center of the ball, bottom of the
I
ball?
think the bottom.
Yeah.
Would seem to work better.
Yeah, okay.
Why the bottom of the ball?
That's the part that hits the ground when it bounces, so that would probably be the most accurate measurement, I would think.
So when it hits the ground, it's at the bottom. So at the top, you'll be measuring the,
Bottom from
part.
where it hit the ground.
and when you're spotting, you're going to measure the,
Bottom of the ball.
okay. Supplies, tape measures, meter sticks, balls, they're all on the front table.
Okay.
We'll drop it from 200.
I saw 35.
Yeah, me too.
135 at 200.
So 100 now.
When teams have collected data, they should move on to problem 222. As they graph their data, they should find that a line fits their data and recognize that the slope of the line represents the ball's rebound
Work with
ratio.
your team to generalize by considering parts A through G below. Okay, part A. In problem 221, does the height from which the ball is dropped depend on the rebound height, or is it the other way around? With your team, decide which is the independent variable and which is the dependent variable.
I think it's the other way around.
Yeah.
Because the height from which you drop is independent, but the rebound height depends on where you drop it from, so therefore it's dependent.
Well, yeah. Our data table shows that.
Yeah.
Okay.
Yeah.
Okay.
So. Okay. Part
So yeah, just we draw an x and y axis, but we'd only use quadrant 1 because there can't be a negative bounce.
Yeah, because
Yeah.
it's at 0, it's at 0. Okay.
So
B. Graph your results on a full sheet of graph paper. Okay, we should graph it.
alright.
What pattern or trend do you observe in the graph? Do any of the models you have studied so far, linear or exponential functions, seem to fit? Okay, so let's graph it and see what we get.
Alright, my axis ready.
Okay, so let's plot the points.
I'll stat plot it on the calculator too.
Okay, I'll read
Yeah,
them
so
for you
I-
guys. Okay. The first one is starting height 200, rebound height 138. What pattern or trend do you observe in the graph of your data? Do any of the models you have studied so far, linear or exponential functions, seem to fit? If so, which one? Does this make sense? Why or why not?
It's pretty steady.
Yeah, it looks
Yeah.
linear to me.
And on the calculator too, it looks like a line almost.
Right. I mean, it doesn't look like exact like slope of 1, but almost like 3/4. Like it's not totally steep enough to be 1, but it's pretty darn close.
Okay, well, let's see what part C says to do. Part C says, draw a line that best fits your data. Should this line go through the origin? Why or why not? Justify your answer in terms of what the origin represents in context of this problem. So we should draw, here's a straight edge. You can draw a line.
Okay.
I think it should go through the origin because when you drop the ball at 0, it doesn't bounce at all. So it
Yeah.
stays
I think it should
around.
end at the origin because, I mean,
Well,
it's not
right
gonna be-
begin.
Yeah.
end. Okay. So it does go through the origin. You got a line?
Yeah. pretty
Okay.
close.
Okay.
D, find an equation for your line. So we know that the y-intercept is 0 because it goes through the origin. So I guess we should find the slope.
Yeah, and like because it looks like the line we saw earlier, it kind of looks like a 3/4.
Okay, do you want to test it?
Yeah, sure. Can I, any different color pen or
I have a
anything?
blue pen.
Cool. Thanks.
And I'll type in 3/4 onto the
Yeah.
Y
and
equals.
maybe try it. Mikey, you can test another one maybe?
I mean,
Yeah, it goes through.
it's a
the
teeny
data
bit
points.
steeper, but I mean, it's pretty darn accurate.
Yeah, same with the
Yeah.
calculator.
Oh yeah, it goes like right
Oh,
there.
that's darn near perfect.
So
Yeah.
Pretty close.
our equation is y equals 3/4 x.
And there's no B point because B is 0.
It goes through the origin.
So you guys got one that works.
Yeah.
That's great. Did you try other equations? See if you can get a little closer. You're at 0.75. Do you want to try anything a little closer?
Oh yeah, well, it's a teeny bit steeper, the
From
3/4,
Jimmy's trend
than the my trend line. So you want to try like,
But I think that one goes through it better.
do you want to try just to see how it looks?
Yeah.
Did you calculate the rebound ratio?
Yeah, it's 7. Or no, it was 72%. So you want to try something like 0.72.
0.72? That sounds good.
Go to.
Wow, that's exact, almost.
For closure, have teams share their rebound ratio. In the next lesson, students will use the rebound ratio to make predictions about the behavior of their bouncy balls.